A very good morning, students. Today we'll be learning about floods. Floods occur when peak discharge exceeds channel capacity, and this may be brought about naturally by intense precipitation, snow and ice melt, storm surges in coastal regions and the rifting of the barriers such as ice dams, or by the failure of man-made structures, by deforestation, urbanizations which reduce infiltration and interception, and by engineering work such as land drainage or the strengthening of embankments of the rivers. Objectives. In today's class, we'll learn about the meaning of the floods, causes, flood-prone areas in India, flood control and management, flood control program and strategies, approaches to flood management, urban floods. Flood has also been defined as a state of high water level along a river channel or coast that leads to inundation of the land which is normally submerged. Flood is an important component of hydrological cycle of a drainage basin. In fact, droughts and floods are the two extremes of the hydrological cycle. While droughts occur due to the failure of rainfall, floods generally occur in the event of excessive rainfall. Thus, flood is a natural hazard which occurs in response to heavy rains, and it becomes a disaster when it inflicts heavy loss to life and property. Now let's look at the causes of floods. The main causes responsible for the occurrence of floods are meteorological, geomorphic, anthropogenic. Meteorological factors include heavy rainfall, snowfall due to tropical cyclones, and cloud burst. Most of the floods in India are the result of heavy precipitation, especially during the season of southwest monsoon. Geomorphic factors like the large catchment area of a river, gentle slope and the low gradient of the river course, and the poor drainage also lead to floods in the northern plains and coastal plains of India. The Jodhpur, Barmer and the Bikaner flood in July 2006 mainly occurred due to the cloudburst and poor drainage in the region. The July 2005 flood in Mumbai was mainly due to the construction of houses and structures in the bed of the Methi river. Now let's look at the flood-prone areas of India. Out of the country's total geographical area of 329 million hectares, about 45 million hectares, which is 13.6% of it, is prone to floods. The flood-prone areas of India are, an examination of these regions shows that the flood-prone areas are well scattered in different parts of the country, ranging from heavy rainfall areas to the scanty rainfall areas. Flood is, however, a recurring feature during the rainy season in Assam, West Bengal, Bihar, Uttar Pradesh, Haryana and Punjab. Floods also occur along the eastern coastal plains, the valley of Kashmir, the lower reaches of rivers discharging their water in the Bay of Bengal and the Gulf of Khambat. The flood-affected areas of India are the Ganga river basin, the Brahmaputra river basin, the Punjab-Haryana floodplain. Now let's look at the regions individually. The Ganga river basin, stretching over an area of about 8,61,400 square kilometers. The Ganga and its tributaries drain the states of Uttarakhand, Himachal Pradesh, Haryana, Uttar Pradesh, Bihar, West Bengal, Jharkhand, Chhattisgarh, Madhya Pradesh and Rajasthan. Its large left-hand tributaries are Sharda, Kali, Gomti, Ghagra, Gandak, Kosi and Mahananda, while the right-hand tributaries include the Yamuna, Chambal, Sindh, Betwa, Ken, Son and Damodar. Thus, from the mighty Himalayas in northern peninsular India, the Ganga and its tributaries carry enormous quantity of water. These rivers, due to heavy rains in the rainy season and melting of snow in the spring season, cause heavy floods in the middle and the lower reaches of their catchments. Kosi means Q's Kosana, which has often been called the sorrow of Bengal. Its flood in July 2008 caused heavy loss to the life and property. The cloudburst on 16 June 2013 in Uttarakhand resulted into a disaster in which sacred places such as Kedarnath, Rambara, Rudraprayag, Srinagar, Joshimath, etc. were seriously damaged. Floods are largely confined to the northern part of the state, where occurrence of flood is an almost annual feature during the season of general rains. The rivers like Burhi Gandak, Bagmati, Kosi and the lower reaches of the Mahananda spill over the banks and inundate the low-lying Khadar areas. The Kosi flood of 2009 created havoc in the districts of Sahasra, Medhapur and Khagaria of Bihar. Many of the cities and towns were submerged under water, causing enormous loss to life and property. In West Bengal, the southern and the central parts are frequently flooded during the season of southwest monsoon. The Mahananda, Bhagirathi, Ajay and Damodar, which is also called the Sorrow of Bengal, are often in floods in rainy season. Next, we'll look on to the Brahmaputra river basin floods. The maximum discharge of water among the Indian rivers is in the Brahmaputra river. The Assam Valley is considered to be one of the worst flood affected areas of India. In fact, in Assam, floods are almost an annual feature. The Jaldhaka, Teesta and Torsa rivers often overflow their banks. The main cause of floods in the Brahmaputra basin are heavy and torrential rainfall. During the rainy season, over 200 centimeters of rainfall is recorded over greater parts of its middle and lower reaches. Silting of the river course due to heavy soil erosion, landslides, heavy pressure of the population and shifting cultivation on the surrounding hilly areas. All these factors collectively result in flooding of the vast areas in and around the Brahmaputra valley. All the districts of Assam are inundated almost every year. The worst affected areas in Assam are Majuli, which is India's largest riverine island, Dhubri, Kokrajhar, Byarpeta, Guwahati, Mangaldoi, Sibsagar, Jorhat, Dibrugarh and Tezpur. According to one estimate, about 80 lakh hectares, that is over 45% of total area of Assam is flood prone. Now let's look at the next flood prone region, the Punjab-Haryana floodplain. This area falls under the scanty rainfall recording areas of India. Despite low rainfall, Punjab and Haryana are adversely affected by floods because of the inadequate surface drainage. In Punjab and Haryana, the rainfall water is waterlogged. Consequently, the ill-drained areas are inundated. The rivers like Satluj, Beas, Ghaggar and Markhanda record floods almost annually. The main reasons of floods in Punjab and Haryana are deforestation in the lower Himalayas and Shivaliks, an increase in the soil erosion in the upper reaches of the rivers leading to silting of the riverbeds, the construction of structures in the Bet, that is the Khadar regions of the rivers, unscientific land use, cropping patterns and rotation of the crops, and the obstruction of natural drainage by the construction of roads, railways and human establishments. Floods are frequent in the Ghaggar plain of Punjab, Haryana and also Rajasthan. The Ghaggar river is seasonal in character. Its course disappears in the sand dunes of Rajasthan after crossing Punjab and Haryana. Now let's look at the flood prone areas of the coastal plain regions. The coastal areas of Odisha, Andhra Pradesh, Tamil Nadu, Kerala, Maharashtra and Gujarat are included in this region. The magnitude of floods becomes serious in the lower reaches of the Mahanadi, Godavari, Krishna and Kaveri. The beds of these rivers are shallow, which inundate after a heavy downpour in their catchments, indiscriminate felling of trees in the catchment areas of the main rivers and their tributaries has accelerated soil erosion and silting of the riverbeds. The occurrence of tsunamis as on 26 December 2004 led to serious damage to life and property of the coastal areas. Now let's look at the flood control and how to manage it. Let's talk about the approaches to flood management. Approaches to dealing with floods may be any one or combination of the following available options, which are attempts to modify the flood, attempts to modify the susceptibility to flood damage, or attempts to modify the loss burden or bearing the loss. The main thrust of the flood protection program undertaken in India so far has been an attempt to modify the flood in the form of physical, which is structural measures, to prevent the flood waters from reaching potential damage centers and modify susceptibility to flood damage through early warning systems. Now let's look at the structural measures. The structural measures are generally adopted for flood protection include embankments, flood walls, sea walls, dams and reservoirs, natural detention basins, channel improvement, drainage improvement, diversion of the flood waters. And now let's look at some of the non-structural measures. Non-structural measures include flood forecasting and warning, floodplain zoning, flood fighting, flood proofing, and flood insurance. The main steps taken by the Government of India for flood control and management are, firstly, the flood forecasting. The Central Water Commission started flood forecasting since November of 1958, when the first forecasting station was established at the old railway bridge of Delhi. Since then, it has extended the flood forecasting stations to cover almost all the major flood-prone rivers of the country. At present, there are 175 flood forecasting stations on different major and minor rivers of the country. The centre issues daily flood forecasts and warnings throughout the season of general rains. The Central Flood Forecasting Organisation monitors floods all over the country and issues warnings. The main flood forecasting centres are located at Surat, which is on the Tapi River, Bharuch, Narmada River, Varanasi, Buxar, Patna and Hatida and Ahmedabad for them on Ganga River, Dibrugarh and Guwahati, which are near Assam, and Japulgai near Teesta, and Delhi we have Yamuna River, Lucknow, Gomti River, Bhubaneswar, Subarnarekha, Burtha, Balang, Brahmani and Baitarani, Sahibi, Rajasthan and Gandhi Sagar, Chambal. In addition to these, there are 157 flood forecasting stations from which about 6,000 forecasts are issued every year. Now, flood forecasting and warning network in India. Of all the non-structural measures for the flood management which rely on the modification of susceptibility to flood damage, the one which is gaining increased or sustained attention of planners and acceptance by the public is the flood forecasting and warning, which enable forewarning as to when the river is going to use its floodplain, to what extent and for how long. As for the strategy of laying more emphasis on non-structural measures, a nationwide flood forecasting and warning system has been established by the Central Water Commission. Flood forecasting and flood warning in India commenced in a very small way in the year 1958 with the establishment unit in the Central Water Commission, New Delhi. This has now grown to cover most of the flood-prone interstate river basins. The Central Water Commission is currently responsible for issuing flood forecasts at 173 stations, of which 145 are for river stage forecast and 28 for inflow forecast. In case of the inflow forecast, variations within plus minus 20% are considered acceptable, as a result of which the flood forecasting and warning services have rendered immense benefit to those in the flood-prone areas. Modernization of the flood forecasting services. The Central Water Commission is making a constant endeavour to update and modernize forecasting services on a continuous basis to make flood forecasts more accurate, effective and timely. Initiatives being taken for modernizing flood forecasting services are the establishment and modernization of the flood forecasting network, including inflow forecast through automated data collection and transmission, use of satellite-based communication systems through very small aperture terminals, and improvement of forecast formulation techniques using computer-based catchment models, and development of a decision support system for flood forecasting and inundation forecast model for the Mahanadi Basin and the flash flood forecasting for Sutlej Basin. Development of a real-time flood forecasting system for the Brahmaputra and the Barak Basin, envisaging data collection through automatic sensors and transmission through satellite and forecast formulation using a computer-based mathematical model. Now let's look at the second feature of the flood management in India, reduction of runoff. Reduction in runoff is one of the most effective methods of flood control. Runoff can be reduced by inducing and increasing the infiltration of the surface water into the ground. Afforestation in the catchment areas of the rivers is a very effective step to check the runoff and to increase the percolation of water. The next effective feature is the construction of dams and reservoirs. The floods can be reduced by construction of dams and reservoirs. Dams have the capacity of holding huge quantity of water during the flood period and help in reducing the menace of the floods. Water stored in reservoirs of dams can be released under controlled conditions depending upon the carrying capacity of the river channel. A number of dams across the Damodar, Kosi, Sutlej, Rihand, Mahanadi, Krishna, Kaveri, Chambal, Narmada, Tapi and Sabarmati have been constructed to check the floods. The next feature, the control of the flood levels. A number of steps may be taken to control the flood levels. Among these steps, stream channelization, channel improvement and flood diversion are important. The next important feature of flood control includes the construction of embankments. Construction of embankments is a very effective method against floods. Construction of embankments has been taken in a big way after the establishment of Central Water Commission and the Flood Control Commission. Over 12,000 kilometer long embankments have been constructed after the establishment of the Flood Control Commission. Our major embankment projects taken up after independence are on the rivers Kosi and Gandak in Bihar, Brahmaputra in Assam, Godavari and Krishna in Andhra Pradesh, Mahanadi, Brahmani, Baitarani and Subarnarekha in Odisha and Tapi in Gujarat. These embankments play an important role in providing reasonable protection to vulnerable areas. One of the important flood moderation examples achieved by dams is that of Damodar Valley, where 4 reservoirs were constructed with flood management as one of the objectives. During the 2000 monsoon, the Damodar Valley Corporation reservoirs saved the life and property of people from a possible disaster through flood moderation. Barring occasional breaches in the embankments, these works gave reasonable protection to an area of some 16.5 million hectares. The next feature of the flood control, the floodplain zoning. Floodplain zoning is another very effective method of flood management. It is based on information regarding land use in the floodplains. Some areas are more prone to floods than the others. Construction of buildings, factories, etc. in the zone adjacent to the river channels should be prohibited. The areas occasionally flooded after a few years should be under green belts in which social forestry is a priority. Regular dredging of the river beds, the formation of the national water grid through which flood waters could be diverted to dry areas through diversion channels or could be stored in reservoirs, and next to develop suitable drainage channels in waterlogged areas and engineering effective methods to protect the coastal areas from tides and sea surges. Now let's look at the flood control program and the strategies. The National Flood Control Program was launched in India after the devastating flood of 1954. The program consists of 3 phases which have been briefly described. The immediate phase, this phase extends over 2 years and includes the collection of basic hydrological data and execution of immediate flood protection measures like construction of embankments, improvement of the river channels and raising the vulnerable villages above the flood level. The short-term phase, this phase lasts for next 5 years. In this phase, there is an emphasis on improvement of surface drainage, establishment of the effective flood warning system, shifting or rising of the villages above the flood level, construction of diversion channels, construction of embankments and raised platforms to be used during the period of floods. And next, the long-term phase includes construction of dams, storage reservoirs, digging large diversion channels, taking suitable steps for land use improvement and soil conversion in the catchment area of the main river and its tributaries. Urban flooding is significantly different from rural flooding as urbanization leads to developed catchments which increases the flood peaks from 1.8 to 8 times and flood volumes up to 6 times. Consequently, flooding occurs very quickly due to faster flow times in matter of minutes. Urban areas are densely populated and people living in vulnerable areas suffer due to flooding, sometimes resulting in loss of life. It is not only the event of flooding but the secondary effect of exposure to infection also has its toll in terms of human suffering, loss of livelihood and in extreme cases loss of life. Urban areas are also centers of economic activities with vital infrastructure which needs to be protected 24/7. Now, the guidelines which is issued by National Disaster Management Authority, let's look at it. As a part of the mandate, the NDMA has made efforts to prepare the national guidelines on management of urban flooding. Even though urban flooding has been experienced over decades in India, but sufficient attention was not given to plan specific efforts to deal with it. On the riverine floods affecting large extents of rural areas, Mumbai floods of July 2005 turned out to be an eye-opener, realizing that the causes of urban flooding are different and so also are the strategies to deal with them. NDMA has for the first time decided to address urban flooding as a separate disaster, delinking it from the floods. Urban flood risk in India. There has been an increasing trend of urban flood disasters in India over the past several years, whereby major cities in India have been severely affected. The most notable amongst them are Hyderabad in 2000, Ahmedabad in 2001, Delhi in 2002 and 3, and Chennai in 2004, Mumbai in 2005, Surat in 2006, Kolkata 2007, Jamshedpur 2008, Delhi 2009, Guwahati and Delhi in 2010, and many more. A special feature in India is that we have heavy rainfall during monsoons. There are other weather systems also that bring in a lot of rain. Storm surges can also affect coastal cities or towns. Sudden release or failure to release water from the dams can also have severe impact. In addition, the urban heat island effect has resulted in an increase in the rainfall over the urban areas. Among the important cities of India, the average annual rainfall varies from 2,932 millimeters in Goa and 2,401 millimeters in Mumbai on the higher side to 669 millimeters in Jaipur on the lower side. The rainfall pattern and temporal duration is almost similar in all these cities, which receive the maximum rainfall from the southwest monsoons. The average rainfall for the month of July in Mumbai is 868. Stormwater discharge systems in the past were designed for rainfall intensity of 12 to 20 millimeters. These capacities have been getting very easily overwhelmed whenever rainfall of higher intensity has been experienced. Further, the systems very often do not work to the designed capacities because of very poor maintenance. Encroachments are also a major problem in many cities and towns. Natural streams and watercourses have formed over thousands of years due to the forces of flowing water in their respective watersheds. Habitation started growing into towns and cities alongside rivers and watercourses. As a result of this, the flow of water has increased in proportion to the urbanization of the watersheds. Ideally, the natural drains should have been widened, similar to the road widening for increased traffic, to accommodate the higher flows of stormwater. But on the contrary, there have been large-scale encroachments on the natural drains and the river floodplains. Consequently, the capacity of the natural drains has increased, resulting in flooding. Improper disposal of the solid waste, including domestic, commercial and industrial waste, and dumping of the construction debris into the drains also contributes significantly to reducing their capacities. It is imperative to take better operations and maintenance actions. Conclusion. Floods are a recurrent phenomenon in India. Due to different climatic and rainfall patterns in different regions, it has been the experience that while some parts are suffering devastating floods, another part is suffering drought at the same time. With the increase in population and developmental activity, there has been a tendency to occupy the floodplains, which has resulted in damage of a more serious nature over the years. Often, because of the varying rainfall distribution, areas which are not traditionally prone to floods also experience severe inundation. Thus, floods are the single most frequent disaster faced by the country.